Hi. So super fast, I want to cover vanishing gradient because this can be a little confusing. So you know how to optimize our gradient descent? We do weight is equal to weight minus our learning rate times the derivative of our w, right? Now imagine w is some number of neurons, and let's just say n or something, right? So like that. Actually, you know what? Let's just do logistic regression, right? Simple models, easy to explain, and you'll get an intuition for other forms of neural networks, right? So let's say logistic regression, right, where we take the sigmoid of z, which produces y hat, right, and y hat, and obviously the inputs, right, from x1 to xm are going in there, right? Whatever xm is. Let's say there's 100 inputs, whatever. So now, um, what happens is if we're not careful with our weight initializations, right? And let's say our w is a x by 1 vector, right? If it's an x by 1 vector, and let's just say we're not careful with our weight initializations, right? And we go around and we initialize our weights to very, very small numbers, right? So let's say 10 inputs, for instance, right? A 10 input model. And our weights are all between 0.01, for instance, and the variance is between 0.01 to, let's say, 0.05, right? So now, what's going to happen, and let's say our inputs are small too, right? Let's say our inputs are small. Let's say our x's vary from 0.06 to, I don't know, zero point 0.2, right, for instance. So very, very small numbers. And we went around and we initialized our weights with very, very small numbers, right? And this is just a variance for our weights. So, and our inputs are small. So can you guess what's going to happen here? If we do w minus our learning rate, our weight minus our learning rate, right? That's going to become even smaller, right? And then we multiply that by the derivative of w. Now, what's the derivative of w? The derivative of w. Okay, sorry. So derivative of w, right, in logistic regression is the derivative of z times the times our x, right? Times our x's, and it's just this over and over again, right? For each weight. So now, derivative of z. Now the max derivative of z is zero for sigmoid is 0.25, right? I'm not gonna get into how sigmoid in deep neural networks causes vanishing gradient. I will in 2 videos. I'm pretty sure 2 videos, right? So now we're multiplying this by this. So now our derivative of w is also very small. So now we're just multiplying very small numbers by very small numbers, or we're subtracting a very small number by a very small number, multiplying it by a very small number. So that means our weight is barely gonna change, right? If you think about it, our weight, right? Or sorry, this one, it's barely going to change. So on gradient descent, since our steps are very, very small, we're going to go super slowly, right? And it's even slower than what I'm drawing. So this is vanishing gradient. What's going to happen is it's gonna be hell. You're not gonna be able to optimize it, or it's gonna be extremely slow, and it's just not effective. So that's vanishing gradient. Basically, you're just taking very, very small steps because everything is small pretty much. And we can fix this by being careful about our weight initializations.